Yeah, so we finished with basic theory, with basic architectures. We showed to do, uh, how to run training pipeline, how to code it. But actually, we didn't show you how to do it in a proper way. Like we showed you some notebooks, some IPython notebooks. We showed you pretty good code, but it can be still improved because, as we'll see today, it's hard to do large projects, to do something serious, not in a tutorial way, in IPython notebooks. So let's start with WandB. And before we explain what it is, let's recall that DNN training pipeline. So previous time I said, okay, we have a MNIST dataset with some images, like this one, and we want to classify what is the number on this image. Yeah, we created data set. We had one transform here, which just converts image class to a tensor class. We had data loader. We had 3 networks, fully connected one with nn.flatten, because to work with images, we need a vector, and to get vector from image, we need to reshape image to a flattened vector. We had a convolutional network with some conv2d, and then flatten to do some classification after pre-processing these convolutions. And we had this residual network-like model, where we had 2 convolutions, one downsample, and here residual connection output plus x. And as loss, I said that we can use the nn.cross entropy loss if you have classification tasks, so we used this one. Then I said that we can use TQDM to show progress bar, which is cool to understand how many batches we already processed and how many batches left. What is the expectation of time, of remaining time to finish the epoch. And I showed you how to train one epoch. Parcel also showed you the same examples in another way. Here, as we discussed yesterday, I should add torch.nograd decorator, or it's the same one as inference mode. I guess inference mode like is a newer version which does the similar stuff, but maybe a bit more optimized. I'm not sure here, but you can use either of them. Yeah, so you have one epoch. In one epoch, you have image, label, you put them on device, you run your model, you calculate loss, do backward step, optimizer step, all of this stuff. And here, because we needed some login, we wanted to see how our model actually trains, how good it trains. We wanted to plot this loss curve. We also wanted to plot accuracy curve. We had this average loss calculation here. And in the relation, we had accuracy calculation here and average loss calculation here. And in the main train function, where for each epoch, we update matplotlib plot here. And notice that to do so, we had to create some lists, add our calculated metrics to these lists, then create subplots, do this axis stuff, set the labels. In simpler words, we had to do a lot of work, which is kind of boring, and it's a routine, and we don't want to do it ourselves. Moreover, notice that we had here fully connected network, and we got one plot for fully connected network. Here we got convolution, we got another plot for convolutional network, for example. And the problem is that we can't overlap these 2 plots together in a simple way. Because maybe we want to not look at two separate plots and understand how different models perform during each iteration, during each epoch. But we want to make it more clearer, so we want to overlap these plots, but we can't do it in a simple way without implementing how our matplotlib plots this stuff, or without writing ourselves the code to save this log somewhere, then load these logs and create some other plots. Yeah, so the problem is that plots are cool, we need them, but we are too lazy to implement them ourselves. Here, there are several libraries that can help you with this instead of matplotlib. To help to improve your logging and make it more simple. First of all, why we need logging? You want to measure the quality of your model. For example, does it overfit on training data? So you want to compare the performance on training data and on test data, or on validation data, test data, and so on. Parsers told you about early stopping. So question is, should we stop the training or continue? Maybe our loss doesn't change much and we will just waste compute time. We can already stop and nothing will change. So for this, we need to see how our curve goes. Does the model input looks reasonable or we corrupted too severely? So sometimes when we do augmentations, maybe we did so severe augmentation that our image doesn't look like this class at all. For example, if we come back to this 5, imagine that I show my augmentation only shows you, for example, this corner, this 1, 2, 3, 4 grid cells. You as human won't know that this is 5, and model won't know that this is 5 too. So your augmentation would be too severe and will ruin your training. So to understand whether your augmentation is good enough or it corrupts your data too much, you need to log your input and to see how it really looks like. To visualize it, or maybe if it's audio, to listen to it and understand whether you as human can do something. Also, it's good to log learning rate. Maybe it becomes too small too soon, or maybe it's too large for a too long period of time, and so on. So if you want to do this by our hands in matplotlib, we will need to know matplotlib properly. We will need to add a lot of code. We don't want to do this. So to save, so we don't want to do this. We don't want to run a lot of extra code. We want to be able to visualize different domains of data with ease, like audio, text, images. And we want to compare our models between different experiments, our plots within different experiments. Like we run one model, we run another model, and we want to understand how the curves correspond to each other. Which one, for example, converges faster. So to make it simpler, you can use one of several visualization tools. One of them is WandB, which we'll focus on today. It's easy to use. It has a cool website to monitor logs from different machines. So WandB has its own server, and we can use, for example, I can use the same WandB project on my laptop, and you can use it, for example, on your laptop, and we can see it in the same browser. We don't need to set up this server ourselves. There is MLflow, another popular option, but I found its website less intuitive, and it's harder to compare logs between the models, and it's also harder to compare logs from different machines because you need to set up this server yourself. They don't have like the one server for all users of MLflow. TensorBoard is a rather old option, but it's still popular. And in my experience, it consumes a lot of resources. Its logs can weigh a lot of gigabytes or megabytes, so I don't like it. and I find its user interface maybe also a bit old, but it has some unique cool features like profiler support. So profiler is a technique, or I would say better, like a program to measure what in your pipeline takes the most amount of time or memory. For example, how many seconds you spend on loading the data in your data loader, or how many seconds you used for forward step, and so on. And PyTorch has support for this profiler, and it can save these profiler logs in a TensorBoard style. So you can open these logs in TensorBoard and have a cool visualization. Maybe I can show you like a quick view. There is tutorial here. Yeah, so here it shows you how many threads, how many GPU, how much time you spent on each iteration, what iteration does. So very cool thing to visualize what is a bottleneck in your training pipeline. For example, you can see that you work too much on CPU and don't utilize your GPU, and maybe you need to move your data to GPU faster and do all limitations on GPU, for example. Or maybe move from HDD to SSD disk. Yeah, there is AIM. It's an open source thing. It's clear now. Open source thing similar to WandB. I don't know if it has its own server or not. The good thing is that it's open source, so it's more reliable in the sense that the company won't block you someday, and you can always use it. And the clear ML is advanced stuff where you can do crazy things, not only log your plots, but also visualize your model. Oh, it won't show me like this. Okay, so you can look at this repo yourself afterwards. It will allow you to define your pipelines, models, all of this. But I think it's not like for a single user. It's probably when you have a huge company and you have several engineers which do several stuff, and you need to control what each person do, what each machine do. So it's not like for us, but maybe it will be useful for you when you will work in some huge company. Yeah. So we'll focus on WandB. It's probably the most user-friendly and popular login visualizing tool, logs visualizing tool that exists now. So to use it, you need to install it via pip or conda, like this. And then you just import it and call wandb.login the first time you use it. You can also do this in the terminal. It will be like this. WandB login, I guess. Because I didn't use my... Yeah, like this. So you need to set up it once on your server or on your local machine, and then it will save your API token on your machine. So the first time you use it, it will ask you for an API token, and to get it, you need to log into WandB website. You will log in here, or if you are not registered, you will register here, and you will go to your profile. I won't show it for to avoid its recording, but it's a simple website. You go to your profile, to your settings, and you will see your API token, API key. Okay. Yeah, now let's delete all this handcrafted login and do WandB instead and see how it will work. So in train one epoch, here we can now, yeah, I still calculate this average loss because I want to have average loss across the full data set. But also I can easily log train loss for each iteration, for each step directly. And for example, I can easily log learning rate, and that I don't have to create another matplotlib subplot for this. And I don't have to see how to combine matplotlib from this function with matplotlib from this function, because all I need to do to log the actual metric is to call WandB.log. Then I open round brackets, and I open curve brackets like a dictionary. You use metric name as a key in this dictionary, and you use value of the metric you want to use as a value in this dictionary. Yeah, for example, here we want to log train step loss. We have a loss.item, and we want to log learning rate. We can use a scheduler.getLastLR to do so. And because WandB allows me easily to log all images, audio, all of this, I can do in the same manner a logging of images. I will call WandB.log. I would say that my key is train image. I will call WandB.image and pass the tensor with my image to WandB. Another thing I didn't mention here is step. So step, it says, it means what it means. Like what is the step in your plot you want to put this matrix on. Yeah, for example, if you did 100 iterations and you want, this loss item correspond to a loss on iteration number 50. So your step here will be, instead of this, it will be 50. Okay. Yeah, here you should be careful. There is a common mistake. For example, your image tensor may be not in, it might be the case that you didn't normalize your image to 0, 1. Yeah, so the lowest value in your image is not 0 and the highest value in your image is not 1. And maybe it's like -1, 1. It often happens in GANs. And if you log this WandB image in a such way, it won't show the result properly. It will crop some parts and you will see that something is not right with your image. Maybe the brightness, like the image is too dark and so on. So if you find that your image looks strange without any augmentations, without anything, it's probably because you forgot to normalize it back to 0, 1. We can do the same stuff in evaluation, but here I didn't want to log metrics for each step in evaluation. I just wanted to log the final metric. Notice that I don't need this now. I forgot to delete it. I don't need to save this list. I'm just, again, instead of many lines with matplotlib, I again just call WandB.log and save all my metrics. Now, to run your code with WandB initialized, you need to wrap your code in WandB contextual manager like this. Or you may also do it like this. You call WandB init, and when you do some code, and then you call WandB .finish. It's like another option. You can use either of them, but with the contextual manager, it makes sure that you do not forget about WandB.finish, so it's better to use this one. So you have several arguments here. We won't show right now all of them, but later in a seminar, I will show you some more. So the main ones are project name. In your WandB account, you can have this is my WandB account. You can have many projects here, and you should identify what is your project name. And also, each project can contain several runs. So it's one run of your code, of your program. And you should indicate a reasonable name to avoid forgetting what you did in this run. So if you don't indicate it, it will use some random stuff. But it's better to explicitly write the run name to understand what you did in this run. For example, you name your run like model ResNet, learning rate so, this so, or like model ResNet. Then another run you will call it like fully connected network. And you will know that when you compare these two runs, you compare the same pipeline, but with ResNet instead of fully connected network. Okay, and here you just call your train. Let's see how we can do it for fully connected network, for example. Yeah, we create our network, put it on device. We have optimized, we have scheduler. We call WandB init. I named my project seminar WandB test, and the name FCNet. I will also run the same stuff for convolution. Let's see how it works. Where I forgot about optimizer. 1 second. One, two, three, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Strange. I don't know what was the mistake, but yeah, now you can see that your model is still training. You won't see any plots here. To see the plots, you can go to this website and see how matplotlib-like plots are visualized automatically. Yeah, we can easily see how our learning rate looks like, train loss for each step, some average loss on validation here, average loss on training. And we can also visualize what is our input image. Yeah, so this is like 5, this is 0, 1. Cool, yeah. Let me maybe stop this run because we don't want to waste a lot of time. And let me run convolution just to show how it will look like. Mm. Yeah, we have another FCNet here, the one which didn't work, so I can delete this run. And notice that here I can also change colors to visualize and compare plots more easily. And now I can compare my convolutional network, its plots with fully connected network very easily. Like here, as you see, convolution network converges much faster. We see that accuracy is much higher on the first validation epoch and so on. So we can say that our convolutional network maybe is better for this task, not only at some final epoch, but in general, it curves look better and it suits the task more. Another cool feature in WandB, which is helpful for sharing stuff with your supervisor, so with your teammates, is creating reports. So if you're familiar with Markdown or stuff like that, it's Markdown like online stuff where you can add some text, add your comments, and also show the plots from your WandB project. Yeah, so I can say it like task example project. Yeah, add some description, add subsections. I can show the plots. I can also say like I can insert a slash. I can create headings, lists if I want to. I can add code, maybe table of contents if I want to, a lot of stuff. I can also add this panel grid, which allows me to import logs from my WandB. For example, I want to show images here. I say, okay, add images. And I can like make it as small, as large as I want to. And now I can publish this project and send it for one of you, and you can see and like give your comments here or just understand what I did and so on. Yeah, here's an example, but in Russian, but it doesn't matter. So how it will look like, you have some sections, links, a lot of plots with some explanation maybe, more plots. I'm not sure if I log audio here, but it's also possible to log audio and you can just play audio from this report and so on. You can log audio, text, images, tables if you want to. You could put images and the audio inside the tables and many, many more. Also, I didn't show here, but if you go to a specific run, you can go to a system and it will show you utilization of your CPU, GPU, or memory use for free. You don't need to access and know how to access it. It will do it for you. And you can notice that, if, for example, your GPU is not utilized, or maybe your temperature is too high and you want to improve your server with a better cooler and so on. Yeah, so the profits are automatic comparison of plots. You can compare configs code. I didn't show it because I didn't log the configs, but it also allows you to log the config for your experiment, choose two experiments and compare row by row what is the difference between the configs to understand or to recall what you did, what changes did you make between these experiments. Yeah, you can also log code, but maybe it's not the best idea to log code if you have private code, but still you can log it and also see the differences. You can download log data. You can, for example, log the checkpoint of your model weights to use them afterwards, to download them back from WandB, and so on. Also, downloading log data is useful when you want to use WandB logs in your papers, because unfortunately, or maybe that's just my thing, I don't think that this kind of plots are good enough for papers, because there are not the best, like this naming is more for engineers, not like for publishing and to show to others. And maybe you want to have like another design or choose colors a bit differently and so on. So For me, I prefer downloading the data like this in a CSV format, and then to visualize only the runs I need to in my paper, not on, and only the logs which I need to in my paper instead of doing like print screen and so on. Yeah. From WandB part, that's all. Do you have any questions? Yeah.
I mean, it's just when they're using when you want to make a report, how do you put, like the graphs?
Yeah. So when you want to make a report, let me remove this. So I will have a empty report. You see here it has a phrase type slash for comments. I type slash and I choose here panel grid. Here at the bottom, I can choose which runs to show by making I closed or open. Then I can either say import panel or add panel and see what panel I want to import. For example, line plot. Here I can choose what I want to say, what I want to put in my report. Maybe I want to put validation accuracy. Yeah, it also allows you to put many things on one chart here. But for example, you want only validation accuracy, you put it and you adjust the size. Then you maybe want to have images at the same place. You have it like this. Yeah, you also had a question.
Yes, your dashboard, can I see it?
Dashboard, you mean?
Sorry, just as how private,
So
how secure?
here you see it says private project. So like on GitHub, I can make it public or private. I can also share it with my teammates if I want to. Report, if I have a private project, is also by default private. Also, if I have a private project, it allows me to make the report public with a token access. So I can send a link with a token access, so people will still be able to watch my report, but they won't be able to go here and to see my hardware or anything else. More questions? No. Okay. Let's move to R&D coding part. So here I wanted to discuss how you actually should write code in practice, how you should design your workflow and so on. So in this bootcamp, or if you go to some courses, usually everybody will give you tutorials like this in notebooks or in Jupyter notebooks or in Colab. So IPython notebooks. Yes, this cells with Markdown and Python are called IPython notebooks. Yeah, they're great for tutorials, but because everybody is taught with doing some deep learning with Jupyter notebooks, people start doing Jupyter notebooks everywhere, even if it's not the best choice. And what I wanted to say today is why it's not the best choice. The reason for this is that there are several problems with IPython notebooks which doesn't allow you to develop code in an effective way with a good navigation and so on. Yeah, so it's hard to use notebooks for programs that require a lot of code, flexibility, management, navigation, and so on. Yeah, I wanted to show you this example with example of a keyword spotting notebook. So keyword spotting is like a classification task, but it works with audio. And what it does, it like most of you have like an iPhone or Android, you have a Siri or OK Google or something like this, maybe Bixby, you have Samsung. So your voice assistant triggers when you say the keyword like Siri. Yes, hey Siri, and it will say something. So behind this, there is a deep neural network that listens to you and process your audio chunk by chunk and tries to identify whether you said the keyword in this chunk. So it's a classification task, binary classification task. Is this chunk with a keyword or without a keyword? And that's all. Maybe we don't have a lot of time to cover the whole notebook. Maybe I can go fast through it so you just know how to do such task. It is very similar to image classification. Here I have some config just to make code in a better way, to structure it better, and also to change some hyperparameters more easily. Here you have a data set. You can look at this at home. All you have in your data set is your audio, some augmentations with a transform as I showed you previous time. What is the there is a typo here. So what is the keyword and what is the label? Like a label is one if this audio contains keyword, zero otherwise. For augmentations in audio, one of the popular augmentations is adding some background noise. So what this augmentation class here does, it adds background noise as a white noise or some random noise like from this data set, like cleaning, some bikings or some stuff. Also, there is a gain transform which makes your audio. Can you see it in a? Yeah, and I don't need to zoom. Okay. Can you, what is the gain of your sorry? What is the volume of your audio? You can make it louder or you can make it quieter and so on. Yeah, and you create data set. Good. One function I didn't show you before is the collative fan. So collative fan is used for data loaders, and it tells data loader how to combine the output of get item here into batches. So sometimes, and a common practice actually is instead of returning a tuple like wave keyword label, you return some dictionary like this. But PyTorch won't know automatically how to combine this dictionary into actual batches. To help PyTorch, you create a function called collateFan, and you create these batches yourself. So collateFan has here a data. Data is a list of outputs from get item. As you remember, your data here is each element of this data is a dictionary. So, for example, to create webs and labels here, we append to this webs list element web, in labels element label, and that's all. Here there is such a thing as path sequence. I thought parser should had to tell you about this today, but I don't remember he told. Did he tell you about path sequence? No. So path sequence is a thing when you have audio or time series text of different size. So if you have audio of, for example, 2 seconds length and 4 seconds length, you can't put them in a batch because they will have a different length. The torch won't know what is the proper size of the dimension. So what you do, you use this path sequence, or you can do it by hands. You use this 2 seconds audio and add 2 seconds of zeros, so 2 seconds of silence. And now your first audio in your batch will have also 4 seconds in size. And now you can join these two audios to create a batch. Yeah, and path sequence does this for you. And to call this collective fan, here in data loader, you pass collective fan argument here, and it will combine everything into batches. Here you have model. There is such thing as Mel spectrogram. We will cover it next Wednesday. Attention, it doesn't look like an attention you had today. It's like a different thing. So there is a common, like it's not self-attention, but in some architectures you sometimes use weighted average, where weights are calculated via softmax, and this is called like maybe like attention statistics pooling or attentive statistic pooling or attentive something. And in code you can call it like attention, but it will do something like this. And here it looks like it does this weighted average. It calculates some weights, then it applies softmax to do weighted average. Yeah, for the model, here is convolutional recurrent neural network. So as I told you before, we never actually use RNN transformer. We rarely use transform or RNN or transformer or RNN or fully connected network and convolution on their own. Like we can use them, but usually you combine different stuff, especially in audio. And here you apply convolutions, and then you pass them to gated recurrent unit, which Perso told you yesterday about. And here also there is this attention, which does weighted average. Yeah, and here there's training pipeline, exactly the same as I showed you a couple of minutes before. We just have some other metrics. False acceptance rate, false rejection rate, we will cover it in audio. Just some metrics. We can easily log them again with WandB. Cool. Here I forgot to call train audio, but it will be train audio. So we can also log audio the same way as we logged image. Just don't forget to put it on CPU and maybe convert it to NumPy, because WandB won't be able to work with audio which is on GPU. Yeah. And that's basically all. Now you probably know how to do keyword sporting, at least from the idea point of view. And why I mentioned it, because you saw the notebook. It's pretty good in a sense. You can understand what each part of the code does. But now let's look at this example. Notice that for some reason you start with train one epoch, then evaluate, then only then you do some imports, then you do data set, then your model, for some reason, model is very large. So large that I need to pass, and then you have another data set. So you have one cell, which is enormous. This is extremely bad notebook. But that's actually what happens when you try to do some large stuff in Jupyter notebooks. Why? Because maybe you started with doing some imports, then you did them, and because IPython allows you to run code partially, you can run the first cell and forget about it at all. And then you write your whole notebook, and for some reason you forgot that you need to import stuff in the first cell, and you wrote your training pipeline here at the beginning. And now only you know how to run this Jupyter notebook, so it will make any sense. If I didn't tell you how, didn't show you the original Jupyter notebook with keyword spotting, you won't actually understand what this notebook does. And imagine you work in a company, you have some supervisor, you show him this notebook or her this notebook, they won't understand what you did. Actually, maybe you won't understand what you did yourself after you go away from this notebook for like 1-2 days. And one major drawback here, there are no any, like you misplace the order of things, you put some models, then datasets and models, so you don't structure them together. So it's hard to understand how actually everything works. Yeah, there is a wall of code, hard to navigate, no navigation markers. And that happens because iPattern allows you to run cells in any order you wish. We can look in a better notebook. Now it's ordered. Now everything is in place. But still, there is a problem that there is a lot of code with data sets here, as we see. Still data sets, then models, then again, one extremely large cell with model. Here, I just copy-pasted it because I was too lazy to create a large model. But in practice, your models can be extremely large. If you have some fancy designs, fancy computational graph, where you combine models in a strange way. So this looks bad, and it's hard to understand where everything is located. You need to scroll down and actually look at the code to understand where you write your model, where you write your code, and so on. To improve this, you can add markdown notations, like here, like data set, say that this is my data set number 1, this is my data set number 2, and so on. It's still hard to navigate because I need to use Control F to find V2, for example. Also, I could do it in the previous notebook, but it will be even harder because I don't have markdown navigation markers. Also, Jupyter allows you to have this table of contents here, which will help you with navigation, but still it's not easy. You need to click. You maybe need to install extension for Jupyter to get this table of contents, because Jupyter below version number 7 didn't have this table of contents by default. You need to install it and so on. So to conclude, the notebooks are very hard to structure properly if you have a lot of code. If you want to compare different models, you will have different model classes, and it will be hard for you to actually identify where in your notebook everything is located. This is the first problem. The second problem is configuration. Imagine you want to compare two models, model 1 and model 2, within the same pipeline. In the example above is keyword spotting, or actually in our example here, we needed to do some copy pasting. We needed to call our model, call optimizer just for this model, call train just for this model with a new model, with a new optimizer, with a new scheduler. Maybe we could wrap it in a func, like def model, like this. Yeah, have something like this. It could be possible. But what if you don't want to change only the model? Maybe if you want to change learning rate, maybe you want to change optimizer. If you want to change optimizer, maybe you will need to do if else. If you want to do 10 optimizers, you will have if else, else. So it becomes hard. That's actually not only the problem of Jupyter notebooks, but as Eric told you on Monday, there is Hydra, which helps you with such configuration, but it doesn't work with Jupyter notebooks. That's the case. So having such problems is also possible in native Python, vanilla Python, but in Python you can solve it with Hydra. In Jupyter notebooks you can't. Or at least it will be very hard and not so friendly for you. You can improve it using data class, like I showed you here at the beginning, having config like this and pass only this config. But still, it doesn't look so pretty as Hydra, for example. Now I need to scroll down. Yeah. The third problem is IPython and GitHub. So as we discussed on Monday, Git is essential if you want to work on large projects, to versioning your code, to share it with your teammates, with your supervisor, or to just publish it so people can look at it. And IPython notebooks are not very, do not work properly with IPython notebooks. The problem is that if I just rerun some cell, like this one, after I loaded my notebook from GitHub, Git will think that I made some significant difference. Just because the number here changed, the cell number changed, and GitHub will believe that I made some difference. Yeah, you can do this experiment at home, that clone our repo, try to run, check that no files are modified, then try to run the notebook and run git diff, and you will see that it can show you just that there is a difference, but the only difference is that you ran your cell in different order, or the execution count is different. So this will litter your git difference, and it will make it harder for your colleagues to find what is the significant difference between the previous version and new version, and what is not a significant difference. Also, because IPython easily allows you to abuse the order cells, you can run cells in different orders. Such difference can happen all the time. Also, if we change the actual code in the Python notebook, the difference will look like this. We will be able to see that we changed some code, but it will be in strings here, and there will be also some extra stuff which doesn't actually contain the code, which is just some Jupyter metadata or helpful variables like stores, outputs. We don't care about this, but this will waste our GitHub difference. And if we want to plot something with matplotlib for some reason, and we change our plot, git diff will contain this huge row of changes, which also ruins your, prevents you from a proper understandability and the proper understanding of what were the actual changes in your code. So the conclusion is that IPython is not friendly with Git, IPython and Git are not friends, and it's hard to work with IPython and share your code with your colleagues using Git. Another thing here is IPython and remote programs. So usually when you work with deep learning, you don't train everything on your own laptop, because your laptop may not have a GPU, or your home computer may not have GPU, or you don't want to listen to the noise from your GPU. So you or your company buys you some remote server and you connect to it via SSH. But the problem is when you connect to something via SSH and you close your terminal, the program which you ran in your terminal will also crash. So by connecting to SSH, without any fancy tricks, you will need to always keep your SSH connection running, which is hard to maintain, because maybe I want to close my laptop and go to another place, or maybe my battery is low and so on. So to avoid this, what people have such a thing called TMUX, which allows you to create a session, terminal session. The syntax is like this. You could say TMUX new, for example, I would say project. TMUX new -s project. And now I have a new terminal where I can do some stuff. Maybe I want to do conda activate, F9. Maybe I want to use Python 3. Now to get from this terminal, I type Control B plus D, like this. And now I turn off my terminal. If I didn't use TMUX, my program, my Python would stop running. Now let me open TMUX again. Now, because my session is running, I can say attach to this session, A-T and name of the session. And notice that my Python didn't close. So here, if I want to, I can also run Jupyter Notebook. And I will be able to work on my Jupyter, even if I close my terminal, if I close such connection, or I can run my code on a remote server in Jupyter Notebook. Then when I will connect to SSH, I will check if everything is finished, but the code will keep running. The problem here is that Jupyter and the IPython notebooks doesn't save stuff automatically properly when you close your notebook here. For example, let's do like this. Where is? So we have convolutional network here. And let's do such experiment. I will run this code. And I will leave the page. Yeah. Back to my Jupyter. Go back to my seminar. And try to run the first cell. Note that it's not, it's showing me a star, meaning that it's waiting for other cells to finish. Or it's executing this cell, but this cell is just some import. It shouldn't work so long. This means that my WandB training, which I started, is still running. But if I move here, I will notice that I can't see that my program runs. I have a previous output which I had, which was with a keyword stuff when I keyboard interrupt, when I interrupted my program. So the problem is that even though Jupyter allows you to run code on your remote server with TMUX, and it will run even if you disconnect from your SSH, you won't be able to actually see whether your training is finished or how long it will take for it to finish, like which epoch and so on. So the only thing here you can do is just to wait when you will finally be able to run some import here. See? And maybe this is like the most annoying thing, because you want to know if your training is good, or you want to know what are the new cell outputs, but you just can't see them. And if you did the same stuff in Python here, yeah, for example, let's do like this. While true, print 1. and I will disconnect from it, connect again. It is still printing once. See? So even if I disconnected from my terminal, because I use native Python, I can see that my program is still running. So given these 4 problems, it's hard to do stuff in Jupyter. And we want to move to Python files, to vanilla Python files instead of Jupyter. To do so, we will work in a project style format, or package style format, it's better to say. Eric told you a bit about this, but in general, so you don't want to have a large Python file. It will solve some of the problems, but if you have everything in one large file, it will be still hard to navigate. So what you want to do, you want to split your large file into several ones. So for example, one where you define your models, one where you define your training pipeline, one where you define your data sets, and so on. In Python, for example, as you see from in Torch, we can do from torch import.nn. Yeah, we don't have only one file. We can import sub libraries from our library. We want to our project, our code to also look like this. From name of our project, import, for example, dataset, and now we can use our dataset. How to do it in Python? So we want to have a directory, for example, CRC, or if we did torch, we could call it here like torch. And in Python, you need to say for the Python that this directory is a package. To do so, you add underscore init underscore .py file. Usually it can be empty. I will say in a bit what we can do with it too. Then you have some functions, some other files, for example, some funcs.py, where you define something like maybe some functions, some classes, something. And also you have a main script to run the code, which will import stuff from CRC and do something. Let's have an example. We will create a directory. It shows that I can create because I already created it before the seminar. So let's create a directory. Let's make sure that it's okay. Yeah, we create a directory. We create an empty init.py just to say that our CRC is a package. Now here, to avoid using VS Code or something and to make it simpler for you to understand, I write code directly here using cell magic write file, which allows me to write file to my disk from my IPython notebook directly. I say write file and then pass to the file. And for example, my CRC sum funcs will contain one function, my square, which takes the square, and one class, my neighbor, which does nothing. It has only one argument here. And my main pile will import stuff from CRC. Because CRC is now a package, we added this init file, we can do from CRC import stuff. Like we did from Torch import stuff, now we can do it from our own Python package. From crc.somefuncs, import function and class. And now we can use it here. We can create a variable. We can create a class with this variable, see the initial value, then see the value after we applied my square. And now we can run the code using Python free main.py and see that indeed both our class and my square function work properly. Okay? Any questions here? No. So yeah, we can do this also in our Jupyter notebook instead of, yeah.
And then also do it in the file, but include in the file.
You mean, yeah, I could like, yeah, I could create like a CRC here, yeah, new file here init pi and like main pi from CRC some funcs import stuff, blah 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 blah. I can do it also in the file here. I just wanted to keep it in GitHub when you open the seminar. Yeah, so we can also import this stuff from our Jupyter notebook. It is useful when you have Jupyter notebook, but not like for running all your pipeline, but just to check maybe some functions. Maybe you have a data set and you want to, there is a remark here at the bottom. So one good thing about IPython that you was able to plot example image from the data set and visualize it. But now what we can do, we can from CSC datasets import the name of our dataset. Here it's for KVs, but maybe if we used images, it would be import mnist. And we will be able to run the same cell in our Jupyter notebook, but the definition of the dataset would be in a file, not in the notebook itself. Yeah. So notice here that to import the function, we wrote crc.somefuncs. Because my square function is located in this file somefuncs. But maybe we don't want to have this long path, and we want to be able to import stuff directly from CRC. To do so, we can modify our __init__.py and import stuff with this long path inside this __init. Yeah, so here I write the full path, but now in my main, I don't need to write the full path. I can use directly from CRC. And if you look, it still works fine. Good? Good. Yeah, it is also possible to create nested packages. So maybe you have CRC, then you have some funcs, then you have sub package with some more funcs. All you need to do is just add another init.py. And now we can also do from crc.some package, import something. If we put something in init.py, or if we didn't put something in init.py, we can do from crc some subpackage more funcs, import something, and so on. And we will be able to use it. Good. One thing here, sometimes you want to locate your main script inside CRC, not outside. So let's move main py inside CRC, and let's try to run it. Now notice that, yeah, I can remove this. Notice that you get an error that it can't find what is CRC. That's some Python stuff inside that how Python works. What people usually do, they use like import sys and add this CRC to this sys to your system path, so Python will know where to find this CRC package. But that's bad because modifying your path with some strange packages that you just created, not the best thing to do. So instead, you can just say Python 3 -n crc.main. So instead of having main.py, crc main.py, you remove .py. Instead of slash, you put dot, and you add -m. It says for Python that use as module crc.main. This is the path, and because it's crc.main, it will know that the root is crc and will find other files in crc. And if you run it, everything still works. Good?
Why would you want to do that? This is you hacking, but you chose to violate the normal Python package structure.
You mean why I decided?
Yeah, so you're only having to do this because you put main inside
CRC, yeah.
And
But why?
you were hoping that all of your path imports would work as if you had a substitute.
Yeah, I wanted because my file is still located within the same model, I wanted to be able to run this file directly. So all imports would work. What is the like case when this can happen? So first case, just some people love to use main script to put input scripts in the CRC package. Another case, maybe you have like a dataset class, my dataset. Here you have something, 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 and maybe you want to be able to run this script, to run this file with dataset definition as a script to verify how your dataset works. So instead of having a Jupyter notebook to visualize this stuff like this, you can put this code here. If your name is main, it's just to say like if this is my main script, I want to like strain is my dataset. Maybe I want to have something like this. Let's imagine I called this file like write file the CRC dataset py. Yeah. And just to verify this without IPython, I would be able to run Python 3 minus m CRC dataset. Okay. So yeah, that's a bit of hacking, but there are useful cases when you want to do this. I prefer putting main outside of CRC. Some people may want to put it inside. For example, they can have CRC. Inside CRC, they maybe have a sub package called exp with all experiments, where they keep like train py, maybe inference py, or like inference with some other stuff. Especially when they don't use Hydra, they used to create a separate directory where you keep all of your scripts to run your pipeline in different ways. Yeah. And for this configuration, I didn't mention it here, for the solution part, to solve the problem with configuration, we can use Hydra as Eric suggested you on Monday. So let's move to deep learning case. The hard part, we have about 40 minutes. I'm not sure that we'll be able to show, I will be able to show you the exact example, but we'll see. The main thing is motivation here, I think. So for deep learning projects, we can do the same stuff. We can use Hydra plus for configuration and package style of Python to split things to make it easier to understand where things are located. So we provide you with a cool template here, which contains something from Python dev tools, which Eric told you about, and moves it further for deep learning case. Yeah, for example, you have pre-commit here, like requirements. You can look at this repo afterwards. And you have a lot of packages here. You have CRC, you have datasets package just to define your datasets, loss to define your loss, metrics to define all your metrics, and so on. So your code, your project using such template will be more easier to navigate through. Because if you want to find, okay, where is my teammate, where my teammate created the model, you just go to CRC model and you see that the model is there. Okay. Yeah, and there is train.py outside of CRC, which is the main script for the model. Yeah, the problem with copy pasting from different experiments is also solved with Hydra. I sent you some links on Discord. I hope you read them. And yeah, now my seminar is not structured good enough here. So I have some more comments. Okay, let's do it like this. So, yeah, this project template will be useful for you if you want to do project for our bootcamp or for master thesis project, bachelor thesis, bachelor project, work, PhD, and stuff. Yeah, how you can use it? First of all, you can fork it if you want to. I see that some of you already forked it. You can also use it as a template here. Click on this button. There's a new GitHub feature. So for example, I want to create a new repository, use this as a template. I will call it like bootcamp check. And maybe I want to make it private. I need to wait a bit. And now you have your own project, which contains all the code from the template. Now you can clone it via SSH, for example. Git clone. And I'm copying my new repository. And I can open it here. Yeah, so let's look maybe at train.py, the main script for how to make it larger. Zoom. Oh, now should be fine. Yeah. So here are many tricks which I didn't explain you during the week, but I hope you will get them. So the first, in our train.py, we import some stuff. We import Hydra, NumPy, Torch, and also we import some stuff from our CRC package which we created. I will explain this in a bit. This is just to ignore some warnings, which are user warnings. They are not very important. We can just ignore them. Yeah, there is such function called set a random seed. So as you remember, on Wednesday, we discussed that models are initialized randomly, and you can even initialize the same model twice, and you will get different results because of random initialization. But imagine you ran your program several times and you got a super cool quality. Now you want to run your model again, but you can't get the same quality because you forgot to fix the randomness in your model. To do so, to fix this, you call such function where you fix the seed for all randomness across your model, across your pipeline, sorry. Torch manual seed will fix seed for torch stuff. CodeNN deterministic equal true makes your CUDA, your GPU calculations deterministic, so without any random. If you put it as false, it will work a bit faster, but you can't be sure that your model will return the same result if you rerun if your training pipeline will return the same model if you rerun it. There is also coordinate benchmark. If you put it to true, it will work much faster, but your reproducibility will decrease. What coordinate benchmark does, it looks at what hardware you have, like what type of GPU you have, and it tries to optimize calculations specifically for your GPU. So maybe for your GPU, it is better to calculate convolution like this. And for example, Jeffrey's GPU, maybe it is better to calculate something in another way. And if I move my code from my laptop to Jeffrey's, there might be some problems. Actually, Yeah, and I do the same stuff for np seed and random seed. Random is a Python package. The problem here is that all of this still doesn't help me to make things reproducible across different machines, because how this seed works and how calculations work also depend on the hardware and on all other packages that you use. For example, even if I and Jeffrey again have the same GPU, but he has Python 3.9 and I have Python 3.11, our calculations still might be different, because maybe random work a bit differently in Python 3.9 and Python 3.11. And if I have like V100 GPU and you have, for example, A100 GPU, our calculations still may be different because we have different GPU. Even if we set benchmark here equal false. Yeah, so there might be some problems, but at least to our own machine, we want to have experiments which are reproducible. Now we move to the main part of the function. When we start with set the random seed, then here there is a function which is called setup login, saving and login. What it does, it creates a save directory with inside your root path. Your root path is your repository name. So here root path will be the path to bootcamp check. Then here config train and save dir, the name of the dir where I want to save my checkpoints. By default, it is called saved. So I want my all checkpoints, all my stuff to be logged at this dir. And config writer run name will create a sub directory with the same name as my run in WandB. So it is useful when you want to, as I said, when you use WandB, you want to create different runs to define where is to properly see where you what run corresponds to your model, for example, number one, what for model number two. And here you want to also easily understand where you have checkpoints for such run and where you have checkpoints for another run. Saving init will just create this directory and save your config inside this directory. It will also check if you already have such directory created. So maybe you want to overwrite your checkpoints, or if you accidentally created the same run name, it will check this for you and say, hey, you want to override this stuff? Are you sure? Yeah, and login is just like a print, but it will log stuff in a txt file or .log file. Don't care about this too much. Then we use identify device. Device is also defined in the config as automatic, or it will be a string like CUDA. Then we have some function which defines data loaders and batch transform. So what is batch transform? So sometimes, as I said, you can apply augmentations inside your dataset class. Yeah, like we had, let me show it. Where is it? Yeah, so maybe I want to do transform like this. Inside my dataset class, when I call get item, here I will do some transform. And in this template, it is called instance transform. So this transform is unique or is applied directly at one object in the dataset. But sometimes you may want to apply the same transform, but for several inputs, for the whole batch. You can do it on CPU, but it will be long. And if you want to move your transform to GPU, you at first use data loader to create a batch, and then you apply this transform for the whole batch. And in this template, it will be done here. When you get a new batch, you will put it on device, on GPU, and you will transform this batch here directly. On GPU, it will be much faster, and it can save you, like can increase your speed sometimes like by a factor of 10 even. Yeah, so data loaders. Here I use this thing called instantiate from Hydra, which I hope you read about. So what instantiate does, it allows me to directly define objects inside my config. So instead of having like if config transforms like equals something, batch transforms equals something, else if blah 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 blah. Instead of all of this, I directly define my batch transform object or any other object in my config, and I call instantiate, and Hydra will know on its own how to do stuff. Let me probably show it here. So in my Hydra, I have here, for example, I wanted to call torchvision.transform v2 compose. To do so, I create underscore target underscore, and when Hydra sees such thing, it will know that underscore target that it should create an object of this class with arguments which are passed below. So the transforms argument will look like this. Maybe it's better to have like a model. If you want to create a model, we also will have underscore target underscore and some arguments for this model. Okay. Yeah, and this is a cool feature which allows you to avoid this copy pasting and just use this instantiate, and Hydra will do stuff for you. Just change the config. You don't need to change the actual code. In the same manner, you can create data sets. Notice that you can create data sets which look like a dict of objects, and I can call instantiate on the whole thing. So instead of calling one instantiate for this thing and instantiate for this thing, I can call instantiate for the whole thing, and it will create a dictionary where key train will return this object and key val will return this object. Yeah, and here I instantiate a data loader in the same manner for each of the partitions, for train, for validation, for tests. I use collate-fn from CRC datasets collate. So if you want to modify this code for your task, you will need to go to collate-fn here and modify it somehow. We discussed for keyword spotting what is collate-fn here. For this template, it does a similar stuff. Like your dataset items is a list of some dictionaries, and you just tell data loader how to use this list of dicts to create a batch. Yeah. In the same way, you can instantiate your model and put it on device. Just config.model. Instead of writing any if else or having any copy pasting, you just use instantiate. The same for loss function, the same for metrics. The same for optimizer. You can define optimizer in your config, and you don't need to care which optimizer to use here, in a sense, like to having again this if else and so on. You can change everything inside your configs. And trainer is a general class that does all this training pipeline for you. For now, it's all right. I understand that there are a lot of stuff, and to actually understand how this template works, you will need to spend like a day or two just by looking at the code. But I promise you, when you understand how it looks and you try to implement some task yourself inside it, you will love it so much that you won't do anything in other way, and you won't code in other formats. You will hate Jupyter notebooks, and yeah. It's verified. It's not like because I created this template and I want to use it. It's verified by the high school of economics course where I teach audio, and all our homeworks in this course are designed in a similar template. We didn't use Hydra, so it was worse. Maybe I can show it to you just to see how it looked like. Without Hydra, you could do the similar stuff, but you would need to have a huge configs like this, and you would need to have another class which will parse your config to create to initialize objects. So basically do the same thing which Hydra allows you to do just by importing the laboratory. So without Hydra, you would need to write everything on your own or copy paste a lot of stuff. But notice that if you have a config like this in like a JSON, the problem is that you can't change arguments in command line. What Hydra allows you to do, so I can to run my code to my template, I call python3.trainpy. Sorry. You need to have the latest version of Hydra to work with it. Python3 trainpy. It will create the data set here. It will print you the model to visualize what model you're training, show some useful stuff like the number of parameters, and it will show you the progress bar, which is cool, with some logs to see the loss. And notice that if we did this in MOOCs, actually, I'm not sure if I did this in MOOCs. Good. Then let's do like this. I will create another window. Yeah, recall that I closed the terminal. And everything still works in my terminal, which is cool. And I can see all the logs and know is my training continuous or whether my program crashed and so on. And what Hydra allows me to do, it allows me to say, okay, train py, I identify what is my main config. Here by default it's called baseline.yaml, so I will sell baseline, and I can change stuff very easily. Yeah, let me structure it this way. You can also read it here. So yeah, to run your code, you do Python3 train py -cn config name, where a config name is the main config located in series C configs, like this one, which combines all configs in subdirectories all together. I guess Eric also told you about defaults. So defaults are the defaults value for each variable. Stealth here means that at first use these variables and then override them, but something which is written below the defaults. So override them with something which is written here. Yeah, here we have like optimizer, scheduler. We call this target to import stuff. yeah, to import from a library which is external, which just call it name, write it name. Yeah, and let's imagine maybe I want to change, for example, epoch len. Yeah, instead of creating a new config, instead of doing like this and saying my new epoch len is equal to 10 and having this copy pasting just to change one parameter, what I can do, I can say epoch len equal 10 and change this argument directly in my terminal. Because it is trainer epoch len. It says me that I already created the run with such name, which is true. So it says me, I'm sure that I want to create a run name, a run with the same name. Maybe I don't want, so I say run name equal new run. Yeah, and we can check that now we have a epoch with a length n, with length 10. And the good thing about it, like imagine we have two models. Baseline 2, baseline 2, sorry. Here is the model. It looks like this. Let me create another one for an example. And I will call it baseline model 2. And maybe I want to change it like this. Have here like maybe Likirilu. Here maybe Silu. Maybe I want to have another model like this. To make sure that I can import it from Hydra, I put its name here. Import baseline model 2. I also put it here. Actually, this stuff is not like super mandatory. I can delete it, but let's keep it. And in baseline 2 YAML here, I say baseline model 2. Okay. Now, if I want to run model 1 or model 2, I don't need to create a separate main config. All I can do, all I need to do is to say model baseline 2. And Hydra will understand that it should go to the directory named model and take config which is named baseline 2. It won't work because I didn't override. So trainer override. I didn't change the WandB run name. So in order to run, I call trainer override equal true. It shows me the error that I did something wrong. I guess. And notice that our model changed easily. Yeah, I forgot to put it on the seminar, but yeah, one of the another problems with IPythons or without using Hydra is that if you want to change your config, you will need to create a separate file, or you will need to update your file just by saying like this. You will push this update to Git, and your GitHub will have like millions of commits which just look like update config, update config, update config, update config, update config. This is bad because you just waste comments on one line of changing some commits. And with Hydra, to change, I can change my model, and even after I change my model, I can change its parameters again. Let's say fc hidden equal to I always forgot about this. Yeah, see, it works. So at first it will look at how I overrided the config, the main config, the model config here, and then it will allow me to override the exact variables in this config. So far, so good? Good. Okay, we have 10 minutes. Let me maybe show you some more stuff here. Yeah, so you can create, you have your own config for datasets, config for data loader. You with metrics, you can identify metrics for which you calculate during training and which you calculate during inference. Maybe you want to have separate metrics because if your training dataset is too large, maybe you don't want to, or is too slow, maybe you don't want to waste time calculating metrics on training. Or maybe some metrics should be calculated only during inference and so on. To create your metrics, you again call this target, and you call an instance, you call a class from crc.metrics. Your metrics has a general class named base metric, or base class it is called, which shows you how your actual metrics that you use should look like. They should have like init, they should have a call function, and they should have some name which will be used for logging purposes. Actually, if you create a new class which is a son of this class, you don't need to use name here. You just use this magic where keyword arguments and arguments will contain this name inside. And when you put these args and keywords in super init, which will initialize base class at first, so base metric, they will put name here. And so you don't need to do like this. Yeah. You can keep it like this and it will work. And in this example metric, we just calculate predicted classes and some metric from, I guess, torch metrics. Yeah, some metric from torch metrics. Just an example, maybe you want to have a custom metric written on your own, but in general, they will look like this. You will say its name, to how it should look like in WandB. Yeah, I didn't show you how the project looks like. Yeah, so the template for you will log a lot of stuff. It will log epoch number, all your metrics. Gradient norm, which is useful if you see that your gradient norm is around 0, you have vanishing problem gradients. You need to fix something, your model is not training, or if your gradient norm is like 1 million, you're doing something strange. Also related to this here, no, I guess it is not here by default. So this template allows you to clip the gradient norm. It allows you to clip gradient norm here. So if you want to make sure that you are not using too large steps, your gradient is not too large, you can clip it. to some value, and to do so, you will need to add max grad norm. So trainer max grad norm equal, for example, 5. Notice that I should put plus here, because if my variable wasn't originally in the config and I create a new variable, I need to put plus. Or 2 pluses if I don't care whether it was or wasn't. If it was, it will override. If it wasn't, it will create a new variable. Yeah, so template logs a lot of stuff for you. Some metric to see how fast is your training, how many steps you do per second. All your metrics, your loss. And if you want to log audio, images, and all this stuff, you can do it here. There is a function log batch inside trainer. You will get your batch, and maybe here during training you will say self writer log image batch image. One thing I didn't mention that here all batches are dictionary-like in a dictionary style. So your data set returns a dict object, your collate returns a dict object, and your trainer, your model works with a dict-like object. Here, when you pass dict to forward, it will use, it will automatically identify by this name what is the value. Like if my batch contains a key data object, and I pass this batch to this function, it will see that I have an argument here which is called data object, and it will use batch data object as a value. And my forward here also returns dictionary. This is done to work with dictionaries. It's very useful, very easy to do some stuff. Process batch defines how you process your batches. It transforms batches you need to. It makes sure you zero grade your gradients. You do forward step. You update your batch dictionary with outputs from your model. So you have like a batch with all information from your step. If you have training, you have batch loss. Self-criterion here returns all losses, which is also dictionary, and your main loss is always called loss. So you can do batch loss backward. You clip gradient norm. If it's none, it won't do anything. You do optimizer step, and if you have a learning rate scheduler, you will do a learning rate scheduler step. And then here, you just update metrics for each batch. Here you update metrics for each of the losses. Maybe you have more than one loss. You have one loss, of, for example, for one classification head, and maybe you have another loss for something. We'll cover this in the next weeks when you have like several losses for the same architecture. And here you update all your metrics. And here you will be able to log images, all this kind of stuff. Yeah, base trainer looks a bit large. It creates a lot of stuff. I don't have time to cover all of them. Just metrics here. Defines training process as we discussed. So for each epoch, train epoch for each batch, process batch. There is a check here that if you use too large batch, you won't be able to put it in your GPU. And this will return an error, which is called torch CUDA out of memory. So to keep to see this memory, we put this call in a try except. Yeah, and every log steps, we will do some logging here. And then we will do evaluation for each of the partitions like validation or evaluation. Evaluation epoch looks exactly the same with torch no grad as we discussed. We need to call it to avoid calculating gradients. Here, monitor performance is used to define what is the best checkpoint. It looks at all the metrics and finds which, like, if your metric became better during this epoch, then this is our best checkpoint. Let's save current model weights. If it didn't increase, we want to save checkpoint. But it makes sure that if you, for example, there is one parameter which tells that even if the metric didn't improve, let's log every, for example, fifth epoch, just to save something at least. Move batch to device just moves some elements from CPU to GPU. Notice that you are not always need to move everything to GPU. For example, you have like in audio, you will have audio like which you can listen to, and audio in an image-like format, which is called spectrogram. So maybe you work with spectrograms, but you don't want to work with audio. So your audio can still remain on CPU, but spectrograms will be on GPU. Yeah, and progress bar, log batch, log scalars, log metrics. One thing here, the final one, which maybe we'll discuss today, is a safe checkpoint. So when you work, there might be a problem that your program crashes for some reason after some time. Maybe your server died, or if you work on Colab or Kaggle, your session has expired. So you need to save your to do some checkpoints to save the current state of your program. To do so, after each epoch, or when you each like fifth epoch, or after you achieved the best performance, which you defined here, like monitor, we want to get test multi-class accuracy as maximum as possible. Yeah. If you want to have mean, we will call it here. Where was I was here? Yeah. So we will save our architecture name, epoch number, state dict as model weights. So we will save model weights here in our checkpoint. Also, because optimizers like item also have their own parameters which change during your training, you need to save optimizer state dict and scheduler state dict. So you save them too. Also, you save what was the best metric you achieved and what is your current config. And you save them in the directory which you defined, which was now called saved by default. And then saved, you have new run and testing. So these were the runs which we created. And if you go to testing, we'll see info log and config YAML because it crashed. And in new run, we will have checkpoints for checkpoint epoch 9 or checkpoint epoch 12. And imagine your run crashed, you saved your checkpoints, but now this pipeline allows you to resume your training from the point where you crashed. And even use the same WandB run. So instead of having two WandB runs, like one and continue, you will use the same WandB run. To do so, it will find your checkpoint, load it, set your epoch to the epoch from the checkpoint, your best metric to the best metric from the checkpoint, load state dict, so load weights from the checkpoint, do the same thing for the optimizer, for the scheduler, and maybe you don't want to continue running, but you want to use a pre-trained model. There is also a thing for this, which is called from pre-trained. It is also defined from using config. So if you want to resume from, you will do something like trainer resume from, for example, new run checkpoint epoch in PTH, something like this. And if you want to use from pre-trained, it will be something like this. Yeah. So probably that's all. There are a lot of more stuff, so I suggest you to just go through it, try to understand it. It should be written in a pretty good format, which is understandable, but you need to spend time on it to actually see how things are connected. And once you do so and try to run it, it will work great for your tasks. I didn't do it now, the repository doesn't have a lot of examples. I will do them by the end of summer. So maybe if you want to do such stuff use this during the fall semester, you will have more examples, which will make it easier for you to understand. Yeah. Do you have any questions? No. Okay, then for today that's all. Thank you all for coming.